Good morning, students. So in previous class we studied about inverse trigonometry. In inverse trigonometry we have seen some examples, and also for solving that examples we should know the domain and range. Domain and range of trigonometric functions, inverse trigonometric functions. If you know the domain and range of trigonometric functions, automatically we can remember domain and range of inverse trigonometric functions. If I consider sine inverse of x, what is the domain for sine inverse of x here? Closed interval -1 to +1. What is the range? Range is closed interval -5/2 to +5/2. Okay. So suppose the function is cos inverse of x, y is equal to cos inverse of x, then domain is -1 to +1, then range is 0 to pi. Okay, closed interval. So if it is tan inverse of x, tan inverse of x, domain is capital R, then what is the range here? Open interval -5/2 to +5/2. Then cot inverse of x, cot inverse of x is capital R here, then range is open interval 0 to pi. Then sec inverse of x, here domain is r minus open interval -1 to +1. Okay, except this portion, remaining all the set of real numbers. Then range is closed interval 0 to pi except pi/2. Then cosec inverse of x is equal to, if the function y is equal to cosec inverse of x, then domain is r -1 to 1, then range is closed interval -5/2 to +5/2 minus of 0. So these are domain and range of inverse trigonometric functions. Okay. Now, so based on that we have seen some examples and given some homeworks also. So we'll discuss about homework. So I had given 7th example, sec inverse of 2/√3. We need to find the principal value. What is the principal value of sec inverse of 2/√3? What is the principal value here? If you consider sec inverse of x, so this is called principal value branch. Sec inverse of 2/√3 is that 2/√3 means reciprocal of √3/2. We know the table values. √3/2 means cos inverse. Suppose if I consider cos table value √3/2, at what angle we get √3/2 for cos? pi/6. Okay, 30 degree. So it is the value that 5/6, whether it is lies between 0 to pi. Yes, is it right? That value is lies between 0 to 5 except that 5/2. Sorry, yes, except that pi by 2. Okay, if the given this value is lies between this range, then it is called principal value of sec inverse of 2 by root 3. Next example, that is cot inverse. It is 7th one. 8th one is cot inverse of root 3. So required principal value cot inverse of root 3. It is also pi by 6, correct, root 3. So whether it is lies between the range, yes, of course it is right, 0 to pi, it lies between 0 to pi. So otherwise, if it is not lies between these two, we need to convert, we need to reduce that, right. Then next example, cos inverse of minus 1 by root 2. Here cos inverse of minus theta is there. Cos inverse of minus theta means we can write, if it is cos, pi minus cos inverse of 1 by root 2. So there is one property, that properties we will discuss later on, which is equal to pi minus of cos inverse of 1 by root 2 means pi by 4, 3 pi by 4. So whether it lies between 0 to pi, closed interval, is it true? 3 pi by 4 means 3 into 180, 180 we divided by 4. 4 4s are 4 16, 4 5s are 45 into 3, 15. Yes, that value lies between 0 to pi. Okay. Next, 10th example, cosec inverse. Okay, cosec inverse of minus root 2. Cosec inverse of minus root 2, here cosec of minus theta is there. So that is why minus cosec inverse, by using property root 2 is equal to, so minus as it is, cosec inverse of root 2 means write 5 by 4. Is it lies between the closed interval minus pi by 2 to plus 5 by 2, right. Why I considered minus pi by 2, sorry. So here cosec inverse is there. Cosec inverse means this one, okay, minus 5 by 2 to plus 5 by 2 except 0, that is why this is principal value of cosec inverse of minus root 2, right. Some more examples we will consider. Based on this range only. Okay. Find the values of following. Find the values of the following. So example number 11 we will consider, that is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2 is that. Okay. We will simplify by using table values. Tan inverse of 1 means we can write 5 by 4, okay, plus cos inverse of minus x form. So, cos inverse of minus x form means pi minus of cos inverse of 1 by 2, we will write, plus sin inverse of minus x form, so that we can write sin inverse of 1 by 2 using property. So, we will write the values now by using table. Pi minus of pi by 3, 60 degree, plus into minus here, minus will come, sin inverse of 1 by 2 means 5 by 6, which is equal to 5 by 4. If you simplify this, 2 pi by 3 minus 5 by 6. Take LCM. What will be the LCM here? 4 3 is 12. LCM is 12, right? 4, 3 1s are 2, 3 2s are. Then you can consider 2 1s are, 2 2s are, 12.
Well, next example, that is cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. By using table, that cos inverse of 1 by 2 value is 5 by 3 plus 2 as it is, sin inverse of 1 by 2 is 5 by 6. So simplify this, we get 5 by 3 plus 5 by 3, that is 2 5 by 3. Okay. Next example, example number 13. 13th one, if sin inverse of x is equal to y, then some options they have given 4 options. 0 is less than or equal to y is less than or equal to pi. B, option B is minus pi by 2 is less than or equal to y is less than or equal to pi by 2. C is 0 less than 1 less than pi, and D is minus pi by 2 less than y is less than pi by 2. So y means here, as you see this is given, minus psi y is equal to sin inverse of x they have given. Okay. Then x means domain, y means range. Then in the options they have mentioned y only, means what is the range of this y is equal to sin inverse of x function. Okay. We know already in the interval form, that is minus pi by 2 to plus pi by 2 for sin inverse function. Okay. Next, so we can write it as minus pi by 2. Closed interval is that left hand side, so less than or equal to middle y less than or equal to, that is also closed. That's why less than or equal to pi by 2. So this is the right answer. That's why option B is correct. Next example, 14th one. 14th example, tan inverse of root 3 minus sec inverse of minus 2 is equal to what? Here options are pi minus pi by 3 plus pi by 3 and 2 pi by. These are 4 options. Which one is the right answer? For that we will simplify. What is the value of tan inverse of root 3? Tan inverse, which is pi by 3 minus sin sec inverse of minus 2. Let's sec inverse of minus x form. That's why pi minus sec inverse of 2 is equal to pi by 3 minus of pi minus sec inverse of 2 means here pi by 3 come. Okay, by using table pi by 3 minus simplify minus 2 pi by 3. Okay, minus 2 pi by 3. Sec inverse of 2 is pi by 3. If you simplify this, we will get 2 pi by 3. Pi by 3 minus 2 pi by 3, that is minus pi by 3. Which one is right answer? The answer is option B is the right answer. So these are some examples we have solved by using domain and range of inverse trigonometric functions along with table values, right? So next we'll see the next topic we discuss about properties of inverse trigonometric functions. Properties. Okay, let's discuss some properties. Properties of inverse trigonometry. So, property means let us consider y is equal to sine inverse of x is the function. Y is equal to sine inverse of x is the function. Okay. If you take this sine inverse to left hand side, it will become sine inverse will become sine. So sine y is equal to x will get. Sine y is equal to x will get. Then what happens here? Sine of or sine inverse of sin x is equal to x, because these two are both inverse to each other. A sin inverse of x is a sin inverse outside. Okay, sin inverse of x. We got x here. What is the range? What is the range? X belongs to yes minus pi by 2 to plus pi by 2 close into it if it is sin inverse function. Okay. Then suppose first sine next sine inverse is equal to x only. Okay, x means here range, here it is domain, here it is range. Then what is the range of this function? What is the range? Here suppose sine is outside, sine inverse is inside. Here what happened? Sine inverse was outside, sine inside. Okay, so x belongs to what is the range? Sine is outside means just like sine x power. Okay, if it is y is equal to sine x power, then range will be closed interval minus 1 to plus 1. Okay, then some properties. So in that first one, sine inverse of 1 by x is equal to cosec inverse of x. Here x, here cosec inverse, here sine inverse is there, but here 1 by x is there, here x is there. So what is sine cosec inverse of x means x is domain. What is the domain of this function? Cosec inverse of x function domain. Domain we know already. X belongs to or x is greater than or equal to 1 or x is less than or equal to minus 1. This is also right. Or else we can write it as x belongs to r minus of minus 1 to plus 1. This is also correct. Right? Here cosec inverse of x is there. Here we will not consider sine inverse function. because here sine inverse of 1 by x is there. Okay, so that's why we require here x value, so that we consider cosec inverse of the domain of cosec inverse function. Okay, that is r minus of minus 1 2 plus 1, or else we can write like this, or else we can write like this also, modulus of x is greater than or equal to 1. So all three are equal, right? So we need to prove this. Sin inverse of 1 by x is equal to cosec inverse of x when x is modulus of x is greater than or equal to 1. So let us consider, let cosec inverse of x is equal to y. We have considered. Then which implies, take this cosec inverse to right hand side, it will become x is equal to cosec y. X is equal to cosec y, which implies that cosec y means, yes, cosec y means we require in terms of sine. We have considered the RHS. Okay, RHS is equal to 1. Then we need to convert in terms of sine function. So cosec y can be written as 1 by sine y, or else sine y is equal to 1 by x. Taking it to right hand side, sine y to left hand side, which implies, okay, y is equal to sine. If you take sine function to right hand side, it will become sine inverse of 1 by x. Y is nothing but, okay, from, we consider it as 1, from equation number 1, what we can write? In place of y, we can write cosec inverse of x. Cosec inverse of x is equal to, what is right hand side? Sine inverse of 1 by x. Okay, hence the proof. Next property, same time. Tan inverse of cos inverse of x. Before that, cos inverse of 1 by x is equal to sec inverse of x, where x is greater than or equal to 1 or x is less than or equal to 1. They may give like this, or else you may take modulus of x is greater than or equal to 1. Oh, that's it. Okay. Next, here also it is also same pattern. Let us consider RHS now. Let sec inverse of x is equal to y, which implies x is equal to sec y. Okay, then sec y can be written as 1 by cos y x is equal. Then take cos y to left hand side, cos y is equal to 1 by x. Then y is equal to cos inverse of 1 by x. What is y? Y is nothing but from 1, right? Consider this 1. From 1, we can write in place of y sec inverse of x is equal to cos inverse of 1 by x. properties they ask for 2 marks question. And third one, same time. Third one, that is tan inverse of 1 by x is equal to cot inverse of x when x is greater than 0. When x is greater than 0. It is possible only when x is greater than 0. Positive values. Okay. Now again same right. Let us consider right hand side. That is cot inverse of x is equal to 1. Simplify it. X is equal to cot 1. Then cot y is nothing but 1 by tan y. Tan y is equal to 1 by x. Right. Then y is equal to tan inverse of 1 by x. Then again from 1 in place of y we can write cot inverse of x is equal to tan inverse of 1 by x. See one time. Okay. Next property is, this is one type. In that 3 sub properties are there. So second main type. So in that again 3 will come. That is sine inverse of minus x is equal to minus sine inverse of x. So again we need to write here that x value. They will ask for 1 marks. 1 mark question directly. So this holds good when x value. What is the value of x? Okay. Means we need to remember that here. So to remember, some tricks will use. Here sine inverse of x function is a sine inverse of x function. Then what is the domain of the x here? Then also sec inverse of x was there. What is the domain of sec inverse of x function? That is x is greater than or equal to 1 or x is less than or equal to 1. If it is cosec inverse, that is also same domain. Here sine inverse of x is, what is the domain of sine inverse of x function? That is x domain. X belongs to minus 1 to plus 1. Close the interval. Or else you can write it as minus 1 less than or equal to x less than or equal to plus 1. Is also correct? Okay. Now, how to prove this? Here, let us consider let sine inverse of minus x is there. To make it easy, sine inverse of all that we will consider LHS. LHS is equal to what? Sine inverse of minus x is equal to what? Then minus x is equal, which implies minus x is equal to sine 1, which implies x is equal to minus sine 1. X is equal to minus sine 1. Is it right? Then which is equal, which implies x is that we require sine inverse of minus x is equal to minus sine inverse of x is required. x is equal to, if you take it inside, sine of minus y. Okay. Then take the sine left hand side, because here we require sine inverse of positive x is required. So we need to reduce this minus to plus. That's why what we have done here. Here minus x was there. Okay. That's why we have converted it as positive x by taking minus sign to right hand side. Okay. Or else multiplying by minus sign to the whole equation. So x is equal to minus sine y. In left hand side is 2x. Then sine of, take it inside. Sine of minus theta is equal to minus sine theta. We know the property. In trigonometry we studied that sine of minus theta is equal to minus sine theta. So minus sine theta is equal to sine of minus theta. Now take sine to left hand side. It will become sine inverse of x is equal to minus y, which implies, now multiplying by minus sign again, minus sine inverse of x is equal to y. It is nothing but, what is y here? What is y? Y is nothing but, we can call from 1, we can write it as sine inverse of x. Very simple. Very simple. We'll ask some properties to prove 2 marks. Okay, very important properties. You should remember the properties as well as domain and range of all inverse trigonometric functions. If you remember trigonometric functions, domain and range of trigonometric functions, you can easily remember this one. So, inverse, when the inverse will exist if the given function y, the f of x function, is both 1 1 and on top, then inverse will exist. So here in trigonometry, to make it as inverse, or for making existence of inverse function, first of all we should make f as both 1 1 and 4. So, but there it is not possible for all real numbers. That's why we restrict the domain. Then only the function will become both 1 1 and unknown. So then inverse will exist. That's why the domain and range will vary. Next we will consider, so second main, in the second main it is first property. Second one we choose tan inverse of minus x is equal to minus tan inverse of x. What is the domain? What is the domain of tan inverse of x function? That is set of real number. X belongs to set of. This is also very important. Okay, you should remember for which value of x this property holds good. We'll ask for 1 mark, right? So in that time we need to write that x value. So for what value of x they ask, we need to write x belongs to minus 1 to plus 1. Either you write like this or else you write like this. Both are correct. So here x belongs to r. So same time, how you prove this one? Same procedure we need to follow here. Let us consider, let tan inverse of minus x is equal to y. Next, which implies minus x is equal to tan y, because here we require positive x inside, right? That's why, which implies that multiplying by minus sign on both sides, so x is equal to minus tan y, which implies that, okay, x is equal to, if I take it inside, tan of minus y. Take tan to left hand